Now, the last part of section 2.1, a little bit more challenging. You have to sketch a polynomial that meets the criteria that is listed. So you just start by marking on diagrams and trying to get all the criteria met. So f of x has a range of -3 to infinity. So we don't go lower than that, and we do go up for forever. And it has a local maximum of y equals 1. So that's a local maximum, means at some point it hits 1, but then it's going to keep going up because we don't have our full maximum, because this goes up for forever because our range is to infinity. So as long as we have nothing lower than this line, and we have one point where it's y equals 1, um, and that's our minimum. So we're going to be coming from above because we can't be below that purple line. So do that, and then actually let's go a little bit deeper. And we have a relative minimum y equals 1. So go up to 1. Then we need to make sure that we go down to -3 because that is the domain, or the range, I should say, and then back up. So we double check, and let's forget about this. Does it have a range of -3 to infinity? Yeah, it does. Does it have a local maxima y equals 1? Yeah, it does. That's a maximum within this, is top of a hump, but it's not the full maximum because, well, both end behaviors are going straight up. And that's what you have to do with these. You just kind of have to keep trying and make sure it meets the criteria. So you need to know what the criteria means. All right, quartic function means it's even degree, an end behavior of negative infinity. So that means they're going down on both the left and the right. It's symmetric about the y-axis. So it's the same thing on either side of our y-axis. X-intercepts of -2 and 2. So we need to make sure it's the same on both sides of that line. We need to go through those 2 points, and they have to end up going down. So I'm going to make this go down this way, and this go this way. And then anything else in the middle, it just has to be symmetrical. So I'm going to go here and up here and then down and here. So it's a quartic function. Okay, both end points or end behavior goes the same way, of negative infinity, but they're going down. Symmetric about the y-axis. Yeah, if we flip this sideways, it's the same thing. And x-intercepts of -2 and 2, we got it. We got 2 more here. Again, it just takes practice. So you need to do the homework. Cubic, odd degree. And as x goes to infinity, we go to the right, y goes to negative infinity, goes down. Odds are going to be different direction, so it's down on the right, so it's going to be up on the left. So that's where it's going to be coming from. We need a y-intercept of 0, -3, so we can just plot that right there. We need 2 turning points. And then that's pretty much it. So we're coming from up top, or maybe we should just go up on the left. We need to make sure that we have 2 turning points. So there's one. Actually, we just keep going. Here's one, and here's one. 2 turning points. One minimum, one relative minimum, one relative maximum. We have 2 turning points. It's cubic. And behaviors, we go to the right, we go down, that's true. And the y-intercept is 0, -3. We got everything met. Uh-oh, this is a lot more work. This one's a toughie. So positive -2 to -1. So from here to here, lack of a better way to do it, I'm up here. And from 1 to 2, also positive up here. But these other intervals, -infinity to -2, -1 to 1, and 2 to infinity, so really outside these two things, in between and outside the other way, and it's symmetrical, are negative. So that's going to be down, that's going to be down, that's going to be down. They're going to be negative intervals. But now we also need to have increasing from -infinity to -1.5. So that means it's going up from here, because it's increasing from -infinity. Oops. So it's going through, it's going through. We hit where it starts to go positive, and -1.5, and our x is where it stops increasing. We'll go here, and then back down. And then it's negative here, and it's positive in the green. And that's at positive 1.5. So it's pretty much the same thing, but it's on the right side. So it's symmetrical. And then we keep going down. Now we didn't look at the last thing yet. Is it decreasing from -1.5 to 0? Yeah, it is. Maybe put it a little bit more succinct. But yeah, it has all the criteria met. -2 to -1, the green is positive. 1 to 2, the green is positive. -infinity to -2 is yellow. -1 to 1 is yellow. And 2 to infinity is yellow. And it's increasing up to -1.5. Then it's decreasing down to 0. It's increasing back up to 1.5, and then it decreases down to infinity. So that is our function, and that is how you graph these functions based on criteria. Mark the diagram, mark as much as you can, and double check that it meets all the criteria before you think you're done with it.